kind of sucked into these debates between different understandings of sort of American sort of Protestantism. And I think that's kind of an important thing to recognize. But it's also something that now that I've kind of talked about it briefly, I'm going to step back and not talk about kind of these religious implications, because I really want to, well, to explore kind of Darwin's life in the way that Darwin would himself want it explored, or what he would have seen as his real legacy. And that is not somebody who was a profound thinker on metaphysics or religion, although Darwin was aware his theories had these metaphysical religious implications, and he did think about it. But he was fundamentally a scientist. He was fundamentally, like Charles Daubeny, somebody who wanted to understand the basics of patterns of the natural world. And so I'm going to explore some of his career then as a scientist, to explain where his theory came from, what kind of evidence he drew to develop his ideas, and then also how he sort of extended his ideas of evolution into other types of research programs. So let's begin in that story in the sort of 1820s at Cambridge University. He was a student in Christ College, and to be honest, and I think Darwin would have acknowledged this when he turned up, he was not a particularly impressive student. In fact, the head of Christ College thought that he was basically one of those very common Cambridge students who show up, spend their time hunting and getting drunk, and then panic at the last minute to drag themselves over the finish line when it comes time to study for their exam. And so Darwin does not show a great deal of sort of academic progress early in his career at Cambridge, but that changes when he becomes under the wing of very accomplished and very charismatic science professors, and none more so than the young, the very talented, very charismatic John Stephen Henslow. He was the professor of botany, to the point where Darwin got the nickname the man who walked with Henslow. I mean, you can almost picture Henslow going to the Darwin following after him almost in puppy dog style. He really found his sort of calling in sort of natural sort of history. He'd already had this interest before he came to Cambridge, but it really blossoms under the tutelage of Henslow and then other professors at Cambridge. The geology professor Adam Sedgwick, the resident philosopher of science William Whewell. He also, when he was at Cambridge, becomes familiar with some really important books that kind of change his life, and by changing his life, kind of change the history of science. And so in his autobiography, he said, "During my last year at Cambridge, I read with care and profound interest Alexander von Humboldt's personal narrative. This work, and Sir John Herschel's introduction to the study of natural philosophy, stirred up in me a burning zeal to add even the most humble contribution to the noble structure of natural science. No one or a dozen other books influenced me nearly as much as those two." And talk briefly about these two books, because again, these help kind of make it clear kind of what was motivating sort of Darwin throughout his life. Now, Alexander von Humboldt, a great German naturalist, a decade-long sort of career, very sort of productive scientific thought, but ultimately was most famous for the expedition he took to South America from 1799 to 1804. And then he wrote a number of books about this, but the kind of the international bestseller that really captured Darwin was his personal narrative. This is both rigorous science, but also grand adventure. And so Darwin wanted to partake in that adventure. And Humboldt was not somebody who just went out into nature and simply sort of collecting or observing sort of randomly. He had a goal. My sole true object is to investigate the confluence and interweaving of all physical forces and the influence of dead nature on animate, animal, and plant creation. So how does everything fit together? How does the climate interact with the distribution of species? How do species interact with each other? So these are all really kind of profound questions And kind of central to this is not to look at different parts of nature in isolation, but put them all together as part of a grand whole. So Darwin found this extraordinarily inspiring. The other individual, John Herschel, most famous as an astronomer, but did a wild array of different scientific achievements. Also one of the best mathematicians of the 19th century. And his work, the Preliminary Discourse on the Study of Natural Philosophy, I think is his masterpiece. It sets out what it means to do science. And he doesn't mean it just in a technical sense, but he also means this, what does it mean in a moral sense? And Darwin very much absorbs this moral mission as well. At the very beginning of this book, Herschel writes, and there's something in the contemplation of general laws which powerfully persuades us to urge individual feelings and to commit ourselves unreservedly to their disposal, while the observation of the calm, energetic regularity of nature, the immense skill of our operations, and the certainty which her ends are attained, tend irresistibly to tranquilize and reassure the mind and render it less accessible to repining, selfish, and turbulent emotions. So that's in its kind of fancy 19th century way of saying that science and understanding not just scientific objects in isolation, but the grand influence of natural laws, trains the mind, not just intellectually, but morally. It gives you patience. It gives you a calm that is central to being a good scientist. And Darwin is very much inspired by this as well. And it's this inspiration that he takes with him on the event that he would claim in his autobiography kind of made his career. Through the intercession of Henslow, he's able to get a position as a naturalist aboard HMS Beagle. So from 1831 to 1836, he circumnavigates the globe. Most of the time is being spent in South America. Now, as an aside, this is very much an imperial project. This surveying mission up the coast of South America takes place after the revolutions in South America. So the British military, now that the Spanish and the Portuguese have lost their colonies, the British are trying to move in, not to become the new colonial overlords, but at least to have kind of knowledge about the cartographic knowledge that they can use to protect British sort of interests. And so it's this great imperial adventure, and Darwin is able essentially to tag along. And so as he does this, he very much sort of makes his reputation. I mean, in one sort of way, you can almost see this as the 19th century equivalent of graduate school. He has his undergraduate degree. This is grad school. This is where you move from a young, promising student to an actual practicing naturalist. And his colleagues back in England, even during the voyage, were very impressed with what he was able to accomplish. His professor of geology, Adam Sedgwick, writes to Darwin's old high school teacher. He said that Darwin was doing admirable work in South America and has already sent home a collection above all price. If God spares his life, and actually going out and circumnavigating the globe on a tiny ship is actually dangerous business, but if God spares his life, he will have a great name among the naturalists of Europe. And so one of the things that makes this voyage so important for Darwin is not just it gives him a lot of opportunities to study things like coral reefs or to collect fossils and plants and animals, although that's all very, very sort of important. It gives him the opportunity over the course of years to observe some basic sort of patterns in the natural world. And this is really important. See, remember, he learns from Humboldt, he learns from Herschel, that what scientists do is you want to try to find out how do you tie all these patterns together, not to see the phenomena of the natural world as in isolation, but try to explain it through kind of increasingly general laws. And so one of the things that Darwin, of course, is aware of is these issues of biological function. Now, in the kind of the science of the first part of the 19th century, particularly in Britain, that biological function has a pretty straightforward explanation. God created the individual species. And you might, before you think, well, this is just superstition, you actually, I would say that this is not this is not irrational at all. That if you think about even something as simple as a blade of grass, how nicely designed, or apparently designed to fulfill this function. Then think of things like our eye, our hands, all these other contrivances we see in the natural world. Even today, after scientists who are thoroughgoing evolutionists will still talk in terms of design. And so it does make a certain amount of sense, as well as one important sort of thing you pointed out. You can't have design without a designer. So biological function seems to point to the existence of somebody who's capable of designing that function. Okay, that's fair enough. But one of the things that Darwin is observing, and again, he's not alone in observing this, but he really thinks on this quite hard, is a number of instances where the functional explanation is far from sufficient to explain the patterns that you see in the natural world. So, for example, there are structural relationships in the anatomy of species that cannot be explained purely on a functional explanation. There are spatial relationships, the relationship of different species in space, that don't make any particular sense from a purely functional explanation. And then finally, there are these temporal relationships, the relationships of species in time. Again, that try to explain these merely in terms of design and function. It doesn't work. These patterns don't reduce to function. And so I'm going to go through each of these sort of in turn to kind of illustrate the type of things that Darwin was encountering and he was trying to explain.